Hi, and welcome on board of this webinar, and thank you for attending this webinar about modeling-based digital twins, for which we'd like to present concrete examples. We want to demystify this term, which is very used very often, and show very concrete aspects of it, and explain how to build them. Particularly when they are based on modeling techniques. So the webinar will last 30 minutes, and we will spend the last 5-10 minutes on questions and answers. And for that, you can use the chat window in the webinar device that we're using now. After the webinar, for any pending questions or the question we couldn't have answered, you can also contact the team or contact me using the email address, which is here on the slide, or the contact button, which will be provided on the slide deck, which will be made available to you after the webinar. So with no further ado, let's move on to the digital twin demystification, and first explain in a nutshell what a digital twin is. The basic about architecture modeling digital twins, I'm aware that I may say the obvious for some of you here, but a digital twin is a representation of the state of an enterprise asset or an ongoing process that you need to monitor in your enterprise, because it is important to you, or because you are going to base decisions on it. So the representation is generally made of a model, but in addition to the model, it is fitted with KPIs, with some sort of performance indicators that you will be using to back decisions. And these indicators are collected using whatever techniques, APIs, using the ability to import these indicators in the system that you like to back your decisions. Generally speaking, they are based on actual data, operational data, either real-time or not. It can be based on simulation, it can be based on provisions, whatever the situation. Collected KPIs should be made available and enrich the models you're building. So the KPI data can be mapped and prompted in a context-dependent user interface for users to make decisions or back or trigger the decisions, putting the KPIs in their own business context where they feel at ease to make decisions. And finally, the repository-based representations of the digital twin and the related data can be made persistent thanks to the repository, which adds value to the digital twin to use it for continuous improvement, as we'll see in some of the next slides. So if I now quickly recap what we've seen, we have on the left-hand side an enterprise asset, an enterprise process that you need to monitor. Then you, based on this asset or process, you can build a representation of it, equip it, enrich it with KPIs, and you build a representation and put these KPIs in context. So basically, these are the 5 or 4 simple steps you need to go through to build a digital twin, very generically speaking. It's worth noticing here, taking care of to make the life of the users easier. You can make sure that the final representation that you will provide to the end users is in context. I mean, is in places the KPIs, for example, on maps or on cameras, or in context where the final users will be at ease to make decisions, a context which is as close as possible for the decision maker as his day-to-day life. So if you look at it more closely, finally, what we're saying here, and that's the main message I wanted to convey today, is that it turns out that the representations that we're talking about are models. A model, finally, is a representation of something when you think about it. And if you reverse the idea now, I can state that as soon as you build models, you build digital twin candidates, or at least you build the foundations of the digital twin. You sort of start assembling the components of what the digital twin will actually be. This is the reason why information system designers, IS architects, and all of those who use modeling techniques to solve business issues silently build digital twins foundations, finally. They build the components, some snippets of the digital twins. So how do they do that now? Is an interesting question that we can cover moving on. So you as a designer, as an architect of the information system, may want to literally build models during your modeling activity. And these models are going to be made available as basic representations, for which you will equip and enrich with indicators. So let me give you some examples of that, some concrete examples of what I'm talking about when I'm saying that modelers can build some digital twin foundations. First example we're looking at now is an example where you can imagine that you are a process architect and you're building process models because you need to have a process representation of some sort. It can be just because employees of an organization need to visualize processes to better understand how they are improved, how they can improve them, or how they are going to fix inefficiencies in the process or defects in the process. One of the most commonly used and now standard notation to do that is BPMN, which stands for Business Process Modeling and Notation. And quickly put, processes are represented with BPMN, and they look like, boxes for steps or for activities, and arrows or threads for transition between the steps. So doing so, you get a process map. And now you could enrich this map with indicator values to represent quite diverse situations related to this process. It can be performance, information, it can be throughput. On this example, we have decided to outline bottlenecks, meaning these specific situation when a process slows down for some reason, such as a slower throughput or a lack of results, for example. And to provide a representation of bottlenecks, you can agree on a classical color code, usually red, amber, green, to visualize hotspots and cool spots and draw the attention of the process owners or the users involved in the process executions on the areas for improvement of the process. And doing so, we can say we build a heat map, which becomes a digital twin of the process bottlenecks. Next example I wanted to show is another, again, modeling-based digital twin. Similarly to the previous example, you can imagine that you need to provide project portfolio manager a strategy map to align their execution level resource allocation decisions or the organization strategic decisions. They need to make sure that their decisions at the operational level are aligned on the strategic directions. So to do so, one often uses the concept of capability that helps explain what a company does or is willing to do, and is another standard that we're using here, another standard language that we're using, which is called Archimate. But let's leave the concept of capability and Archimate aside for the moment and focus on what could be the best digital twin for this situation, which is a resource allocation decision situation? Well, one could assume that for resource allocation purpose, the balance and the overall priorities are decided at the strategic level once a year by a budgeting operation, and that to perform any resource allocation decisions down below, one reuses the strategic level resources and the strategic level resource allocation rules and principles, or at least consult them to make sure that there is some kind of alignment. Similarly, to the previous example, then one could build a capability map and enrich it with a cost monitoring heat map, grabbing and consolidating cost information indicators across the organization where they are made available. It could be budgeting systems, it could be other models, meaning strategic models, etc. So doing so, we build a capability heat map. So we turn a capability map into a capability heat map that focuses on the reader's attention, focuses the readers on the expensive or cost-consuming or budget-heavy capabilities, and which depends on how it must be interpreted, at least can be used as a guidance to how to allocate resource at the project operational level. Next example, third example I wanted to show you would apply to application components and would apply, for example, to IT portfolio managers, those who are taking care of renewing the IT assets in the enterprise, focusing on the IT services, focusing on an indicator which comes in mind as soon as you do so, which is obsolescence. Cost is one, the other one is obsolescence. So I'm sure that after the two previous examples we saw, you now have understood the trick and the approach. So this digital twin, in this case, can be used for IT assets or IT portfolio management decisions, such as which applications should be moved to the cloud next. So the three previous examples that we've seen, as you understand, are modeling based. Here in this example, for example, we go from a map of the information system or application components, blue here, to a map which has been turned to a heat map, focusing on those components that are costly, for example, or that in this case are obsolescent. So we see a map in the upper right drawing, upper right diagram that we provided here, but we could also imagine that we reorganize the maps in a different approach, or that we build a report that can be ordered by obsolescence level, for example. Right? So the three examples that we've seen here are clearly modeling based, meaning these models, as you understand, are built by information system architects, process maps, process diagrams, application components diagrams, capability diagrams, and they relate to decisions that can be made in an asynchronous mode. I mean that the related decisions are taken on a rather long term or long horizon of time. For example, which applications should be moved to the cloud on the next cloud moving round, say, is a rather long-term vision and could occur in the next, I don't know, maybe 4 months, 6 months, or a year, right? Sometimes we can also apply the digital twin principles to other types of decisions that are more near real time. This is what I would like to show you now, using other examples that have been built by Axelians using the GenMyModel product in the context of the RESIST project, which is a European R&D project focusing on resilience, meaning focusing on those situations that require quick decisions to go back to normal. So monitoring-based, data acquisition-based, but real-time data acquisition-based type of monitoring. So let's turn you to the first example here, which is about road traffic capture. So we're basically, if you can see the video, we're capturing information from a camera, and the camera is supposed to show us whether things are going normal or not. And we've designed a certain number of indicators that allow to gather captures, detectors, connectors that provide indicator values. So this camera on the left-hand side of the video shows us the ongoing traffic for the moment. And suddenly there is a fire, a vehicle in fire. And you see on the right-hand side that the components in the diagram are reacting real time. Here we have a resilience level, which is explained here in the custom property page of the right-hand side window. And as we move on and as the camera captures the situation, we see on the right-hand side real time, we see the indicators that are changing color, again representing the heat map. It is not a joke, the heat map, because there is a fire, so there is heat. And this lower indicator here, down here, is supposed to capture temperature. You see that this is a thermometer for those who can read. So we capture the temperature. We also capture via the camera, we can capture a fire, we can capture the presence of persons, we can capture vehicles, we can capture the occupancy rate of the road, etc., etc. So this short video shows you a real situation on the left-hand side in the camera and how that can be represented using a model on the right-hand side. And of course, as you can imagine, we could push one step further to make these indicators who are changing colors, the ovals here on the right-hand side, to put them in context for the user to make decision real time again. So if, for example, in this case, firemen should be warned or called, they can be from, for example, a back office or a watch post. Next example I want to show you is an example where we are going to look at, well, I would say health-related, pandemic-related type of situation where in a closed place, in this case a station, we can detect those situations that we mean to detect. So in this case, it's proximity between people and situations like handshaking and things like that. So we see two people here, two people shaking hands. And when people shake hands, we have this indicator on the right-hand side that says, well, finally, there have been handshakes. And we have a shaking hand indicator here that you can see on the lower left side or lower left corner of the screen now. Objects to detect are shaking hands, and here we see that there are shaking hands, and correlatively, immediately the shaking hands indicator, which is in the social dimension package here, is moving to red, right? So that's one example. We have another similar situation a little later in this video where you have, again, people shaking hands. And again, as you can imagine, the detect shaking hands turns red so that we can eventually make decisions on, well, maybe reminding people that in this time of pandemic, we need to avoid shaking hands, avoid contacts. Of course, you knew that you'd have some pandemic-related type of example here. Third example I wanted to show you is how you could, but this will be a fixed image, how you can put these indicators in context. In this case, we apply the previous example to the example of a mall. a mall in which you'd have the map of the mall and some indicators that would tell you what's going on. And on the left hand side and lower side of this video, you have a certain number of indicators going on that allow you to see what's going on, and again in context this time how these indicators are able to react and change color dynamically on a map for decision makers to take whatever suitable decisions need to be taken in this particular case. Finally, the last example I wanted to show you is an example where we're looking at a bigger picture here. We're looking at flood or flooding situation detection, where we are watching river levels, and we're computing based on a rather sophisticated management rule, a compound consolidated indicator called resilience here, based on the acquisition and the consolidation of individual indicators. In this case, we're focusing on 3 different watching stations points of observations from which we have captors that allow us to understand what is the level of the rivers in certain points of the geography. And based on this, we can make decisions. So if we see things going on here, we have placed the same indicators. Let me just go back a few seconds here. The same indicators as the ones that are made available here in this diagram on the right, which are fed by these acquisition components, stations here represented with the yellow rectangles. These indicators are made available at design time within this diagram. But as you can see, we could imagine that we're going to provide the same indicators in context, literally on a map here, which is the actual map of the geography we are in, so that we can really see what's going on. And again, emergency teams, emergency personnel would be able to go and solve whatever situation is going to happen here, because, for example, river levels are increasing due to rain or whatever, and that certain roads, here in this case the ring road around the city, need to be cut or need to be protected so that vehicles do not go, need to be closed so that vehicles do not go on this road anymore. So let me go back to the presentation that we were browsing. So we've seen 3 examples of I would say real-time or near real-time digital twins, where and we've also seen 3 examples of digital twins in asynchronous mode, which are not real-time. So now, what can we say about that? I mean, okay, we've seen how to build digital twins. We've seen what the value they could have, how they could be used operationally speaking. I would like to briefly cover the value and benefits of those who are modeling-based digital twins. First, it allows us to move from analog to digital, looking at beyond the usual borders, if I may say. I'd say that being repository-based, well, here in this case we used the GenMyModel architecture modeling solution by Axeliance, and it has a repository. And thanks to the repository, you can ensure the persistence and the traceability of the data and of the documentation that you're going to be using. In addition to being able to use an API, so you can acquire information from wherever this information is supposed to be available and relevant. But also the next point, and the one I want to outline here, is the ability to perform retrospective and prospective analysis of the data and even of the decisions that have been made based on the information that was provided. Because one can build data analytics, and based on these data analytics, one can analyze decisions after the fact and maybe change the rules or check, perform an audit, say, do we take the right decisions in this or that situation, etc. And more than that, we could also imagine that if we analyze these decisions dynamically again at another level, we can change rules on the fly if rules have to be changed on the fly, because the context can be changed on the fly. Because sometimes the context changes so suddenly that the rules need to be changed very quickly for operational people to behave differently than what was previously agreed. And when rules have to change, the repository allows you that you can immediately go back to these rules and possibly change the rules dynamically. Quickly put, what I wanted to say here about the GenMyModel, which is the modeling environment that we used. Well, it's an online collaborative modeling environment. It's a collaborative modeling platform for information system architecture. Well, if I had to focus on two main benefits of using this type of solution, and this solution in particular, it would be its ability to provide documentation silently with no additional effort than the ones you pay performing the modeling work to build your models and eventually your digital twins. And the second point, which is worth outlining, is the fact that it supports standards. Standards such as I mentioned, BPMN, UML, Archimate, which are very common standards today in the modeling world. Soon, the company will be providing a new version of GenMyModel supporting SysML, which is modeling notation and language, system modeling language used for modeling-based system engineering. So, why is Accidents, the company, and GenMyModel, the tool, different in this in the architecture modeling market? Quickly put, different from the usual players that you see featured in Gartner's and Forrester's enterprise architecture magic quadrants. Well, first, because it's cloud native. So I assume most of you now are using cloud native tools as opposed to desktop tools. And cloud native tools are very practical because they are available to most users. In this case, they provide you with native collaboration capabilities. And as I said, they provide they also provide embedded documentation, integration with third-party tools such as Atlassian, etc., code-free customization and the likes. So it's a very interesting platform when it comes to performing architectural modeling work. If you need to have more information about us, do not hesitate to visit our website and click on whichever link you have provided here and ask us questions. Go on our website to get in touch with us. I will take one or two more minutes to look at the questions that you have asked. And well, there are many actually. And as far as I can see, let me focus on those pertaining to, well, one is about the API. Yes, you're right. I mean, why do we need an API? How can we best use an API to gather information? Well, it is because with an API, you can acquire whatever information is made available to you. We have a REST API in GenMyModel, which is very practical and allows you to connect to third-party tools and to make sure that the information you collect is properly stored in the repository. Another question was about when I said this digital twin design work is repository-based. Yes, as you understand, underneath the modeling platform, you have a repository, which means a database in which you can keep, you can make whatever information persistent, and that allows you to do whatever you need with this information. And you can customize the repository without even coding. You can customize the repository. It's a code-free customization and a significant differentiator for you guys to make sure that you can design whatever you need to design and really adapt to very specific situations here. And I will take a third question, which is sort of a wrong footing of the approach, saying, what about business intelligence? Yes, you're right. I mean, BI can also be used to build digital twins, but I think BI would pertain to the first family of examples we saw where we look back in history to base decisions on what has already happened. Sometimes you're in situations where you need to base decisions on what is happening now, and real time, I mean, and BI may not be the best solution to do so. Last question, which I think is interesting because it goes into artificial intelligence. What about AI to be more predictive? You're right. AI allows you to. AI would be a technique I'd use to audit the decision information to make sure that I can now anticipate on situations and capitalize and make the system smarter, in the sense that I could even feed in the information and make sure that I can update the information and make sure that the decisions then can be improved on the fly. Final question that I can see, which is the last question that arrived just now live. Are you interested in code generation for the future based on models? We already support that. We already support code generation starting from UML diagrams, for example. Okay, I'm aware I'm a bit late now, so I want to thank you all for participating in this webinar. Maybe you're going to be interested in participating in the next one on the 20th of May, which will be a webinar about the benefits of the online collaborative architecture modeling, going more into architecture standards support and collaborative capabilities. Thank you, everyone, for your participation. I hope you liked it. Don't hesitate to provide feedback, and we hope to see you again soon. Bye now.